So, welcome everyone. This is the first Montevideo Tech Meetup of the year, sponsored and hosted by Qualabs. And today we have two great speakers. Andrew, that we met. I personally met you this year on my high video. I have seen a lot of talks from you, but I think this was the first year that we could interact a little bit. And it was a great honor to meet you and see all the work you're doing, regardless, Meetup or Quick, that it's super amazing. The great thing that I love is that Andrew comes from the academic side. So I think he has a very particular overview of the technologies and the video technologies, and he's developing from ground up and the very the roots of the knowledge, and I love that. And also we have today James from Gas Labs, and so it is great. Well, James came this year to the summer camp. So anyone here that say, "Yeah, I have to go to the summer camp next year," blah blah blah, James is one of those that, in fact, he's in Buenos Aires right now because he wanted to escape from winter. So, and he, of course, he came to the summer camp because it's near Argentina. So, anyone interested in the summer camp, so we can ping James about that experience. Thank you, everyone, once again for being here. Today, let's go start with the first talk today. Andrew, I think it will be gracious because of the order of the. No one of you have like preferences, so maybe we can start with Andrew. Uh, Andrew Freeman is going to talk to us today about media bar quicks, some fancy stuff he's had been researching and doing, and I think it's super cool to see all the progress they have. Andrew is assistant professor from the Baylor University. I hope to spell it well, and so please, the stage is yours. And
like Nico said, I'm Andrew Freeman. I'm an assistant professor at Baylor University. I'll be talking, kind of giving the same talk that I gave at Mile High Video last month, and then kind of after that go into a bunch of other things that we're working on with Media over Quick. Just kind of giving an overview of some of the more like research-oriented ideas that we're exploring, and maybe have some time for questions here at the end. So if you want me to go into any more detail, just say so. I have a bunch of slides, so I'll probably just blast through some of them towards the end. But yeah, we'll focus here at the beginning on client-side video analysis for distributed content moderation. So my motivation with this project is recognizing the fact that not everybody necessarily needs ultra-low latency. And to some extent, it might depend on the application and also like what stage in the pipeline you're in. So CDNs definitely need super low latency, but end users don't always need that, depending on what they're doing. So our question that we're trying to explore here is, if a user is willing to sacrifice some amount of latency, what more can we offer them? Is there an added service that we can offer them in exchange for them having worse latency? So therefore, what is a compelling trade-off or compelling application that has a tunable latency trade-off? And as we started to think about this problem, we got on the track of content moderation, and particularly automated content moderation, which is using AI applications to analyze video streams and basically decide if it's okay according to the platform's policies or not okay. But it's very difficult to scale from what I've seen. So there's a question of which streams should be moderated and what is a tolerable impact on latency. So a lot of live streaming platforms, this actually is not very feasible whatsoever because they want relatively low latency. And any additional automated moderation you add is going to hurt the latency for everybody. It's also a one-size-fits-all approach where the platform either says that a stream is okay and can continue to stream, or that it's not okay and they're just going to block that stream for everybody. But in reality, people have sort of different tolerance levels to different kinds of content. So I might be okay with seeing some violent content or a violent video game or something like that being streamed, but I don't necessarily want my child to see that, right? or I might be okay with curse words, things like that. I don't want my child to see that, right? So that's some of the inspiration here as well, is people are going to have their own different thresholds and desires for, what is okay and what is not okay. So to sort of approach this problem, we can compare like a classical streaming protocol like HLS or Dash, but these are typically pretty inflexible for this sort of problem with automated content moderation. And in practice, there's often still a strong reliance on human moderation for these one-to-many live streaming platforms like Twitch, for example. So you might have human moderators that are kind of going through monitoring videos or waiting for streams to be reported, like from the users watching them. And then it tends to be an all or nothing approach where it's either taken down or it's permitted to continue being hosted. And Media over Quick, which is what we'll focus on today, is an in-progress transport protocol for low latency streaming. At least that's sort of what it's billed as. And as opposed to HLS and Dash, it is push-based instead of pull-based, and it uses this publisher-subscriber model with a series of relay services to fan out content to a broad audience. It also supports bidirectional communication between the nodes, which is an important thing that we're going to leverage for a lot of this work. So our idea here is that we could define a number of content categories and have really granular ideas of what we want to look at in the video content. And we can actually distribute the analysis to the receivers of the content rather than doing it all in a centralized server. So the analysis results will then be distributed back throughout the network through a dedicated metadata track in Media over Quick. And through this process, individual users can filter out very specific and granular content categories that they do not wish to see. So this has the benefit of increasing the content safety, blocking bad content that a person's not okay with seeing, at the expense of some added latency. But a key here is that if you are not filtering any content, if you just want the stream as it is, unmoderated, then you have no added latency whatsoever. So that's the big benefit of distributing this analysis to the receivers rather than doing it all server side as it's traditionally done. So at this stage, we have like a relatively simple proof of concept with a strobe application. So detecting kind of flashing lights that could be triggers for people with photosensitive epilepsy. And so in this demo, we kind of show what it's like to have an analyzer and then a filter client and a non-filtering client. So an analyzer is here on the left. I'm going to bring in a strobing impulse, and the filter client has a slight delay. In this case, it's 1 second, which matches the GOP duration. And as soon as the strobing impulse is brought into the view, that client can just stop displaying those frames because it's receiving this information, this metadata information that there is this type of content that it doesn't want to show. So it just stops showing it. And then when the impulse is removed, the stream can resume. So there's potentially, I think, some good social benefit here and health benefits for these particular types of issues like strobing lights. And we propose some major components to make this work. So one is the use of metadata tracks to carry these analysis results throughout the network. We also propose a workflow manager, which decides where to delegate the analysis tasks to in terms of the subscribers, the actual users watching the video stream, and also a filter decision engine, which judges those analysis results that come in to enhance the security. We don't want people giving false reports back and trying to just take down a perfectly innocent stream, or vice versa, giving false results that make it seem like something's okay when it's actually not. So we can sort of look at redundant analyses across several subscribers and use that to make informed decisions about the likelihood that a result is malicious or not. And we've also started to explore how this will work across many relays and complicated topologies, how we convey this information back up through kind of parent relays and distribute that to all of the subscribers. And there is going to be a added latency impact here. The further the data has to travel, the metadata, the worse the latency impact is going to be. But for one-to-many live streaming, we think that this will be relatively tolerable within the range of a handful of seconds. But we're starting to sort of design the logic for this kind of system. And we think that there's some interesting potential impact here. One, it can improve the live stream safety and the accessibility of streaming, especially for people with photosensitive epilepsy, like I said, or people with other triggers that they definitely don't want to see certain types of content, such as sexual content, sexual assault content. If they have a negative history like that, that could be very bad for them. So we can hopefully make things safer and more accessible by blocking that content for them. We can also increase the personalization of streams. So you can decide exactly what your own thresholds are for what you tolerate and don't tolerate, or how you want to respond to certain types of content. Instead of blocking content entirely, you could just blur part of the screen if it has something you don't want to see, or bleep out sounds in the audio stream. We can do that as well. We can support a variety of mixed use cases. And I think this can potentially reduce the CDN costs for providers who do want to provide some sort of content moderation by offloading that moderation, that very heavy AI analysis, to these embedded subscriber devices. That reduces their costs. And then I see a unique potential for new commercialization opportunities where a company can maybe offer kind of moderation as a service, where they provide basically a package with a whole suite of analysis applications for the things you might be interested in blocking. Especially for parents, this could be useful for moderating their children's video content that they can see. And this also has direct implications for video on demand streaming as well, if that is implemented with Media over Quick. So a number of interesting things that could be explored as we continue to try to build this out. Some next steps that we're looking into now are pursuing compatibility with the MoQ streaming format, which would allow us to probably send metadata via this event timeline track that has already been defined there. And then we hope to release an IETF draft specification to solicit feedback and get more improvements, more people in the community to contribute to this, and also release a full open source reference implementation. So those two steps are kind of awaiting the legal approval from Baylor's side, but I think that'll happen soon. Hopefully we can get that process started. And then we're also starting to work on a whole suite of mobile optimized embedded AI analysis applications. So in practice, we foresee that most of this is going to have to be running AI inference on people's phones and like laptop computers and things like that. So we're going to have to design our applications for those lower power platforms, and especially design distribution algorithms to divvy up these analysis tasks to not overload those devices computationally or slow them down or anything like that. So a lot of interesting things to explore. If you want to read our paper from Alhai Video, there's a QR code linked here that you can scan. But yeah, that's kind of an overview of this content moderation idea. We can loop back to maybe open up for some questions here in a minute, but I'm going to first go through some of the other stuff that we have going on. Very broad, high-level overview of how we're really exploring MoQ in our research. So some of the core MoQ work that we're doing is on like low-level optimizations and exploring, how we can develop new strategies that really benefit from using Quick in particular. So we're exploring how we can add support for multipath Quick into Media over Quick so that you could receive data simultaneously across like 5G or 4G and Wi-Fi for greater bandwidth, and what kinds of applications can benefit from that. Evaluating the potential for transport layer adaptation between the relays, and then also how we can better utilize the Quick stream prioritization for heterogeneous traffic between the relays again. So if we have like live sports and also video on demand, and that's all being communicated between two relays, how can we develop quick stream prioritization to handle that in the most cost-effective way, essentially, and provide the best quality of service for the users. This is another talk I gave at Mile High Video. I'm going to go through this super quickly, but we're looking at streaming point clouds across Media over Quick as a particular application. This is a difficult problem because it's a ton of data. So it could be 20 megabytes per frame, even when it's compressed. So extremely high data rates, very slow compression. So this makes low latency streaming very difficult in general. We've explored this through the use of multiple description coding and leveraging quick stream priorities to determine the delivery order when there's network congestion. And then we combine that with this delivery timeout mechanism with Media over Quick. We sort of implemented a simplified version that was tuned to our needs, but it seems to work pretty well. And we have a latency quality trade-off that's pretty cool. So the subscriber can just set a number for like, this is my target latency. And the bigger that number is, the more data they're going to get, and therefore the higher quality the point cloud is going to be. If they set a really low number, they'll have much lower latency. We evaluated down to 50 milliseconds, and it's going to be worse, but we'll still be able to maintain that low latency target. So we have a direct trade-off here that we can explore. We compared this to a Dash implementation, and we saw that that has a much slower warm-up period, whereas MoQ can basically max out the bandwidth very quickly, but it also has these risks of stalling potentially if you're right at that threshold for a long period of time. So we have some work to do to improve that. And then we have developed a proof of concept where we can integrate semantic segmentation within the pipeline to determine what kinds of data, what points we should allocate to different MoQ tracks and how that can improve the experience. So in this video example here, we're receiving the same amount of data in both cases, but with our semantic content-aware segmentation, we can get a much better result that looks visually much more pleasing. Some next steps here. The big thing here is if you're interested in this, you can read the paper here linked in this QR code. Some other topics we're looking at are event cameras, which are these very unique sensors that are optimized for computer vision. They operate at a super high speed, and they do not capture image frames at all, which is a very unique problem. So each pixel has its sort of own independent temporal data stream. And instead of conveying the actual brightness of a pixel, it just says whether or not a pixel got brighter or darker at a very specific point in time with microsecond precision. So very unique challenge from a data standpoint. These can produce up to 500 megabits per second, if even at a low resolution, if there's a lot of motion happening. If there's no motion happening, the camera produces no data. So very interesting problems that we can tackle here. And there's a big need for lossy streaming that has really been underexplored in the literature. Most people are focusing on just developing the applications, assuming that all of the data that the camera produces can arrive in a reasonable amount of time. But for practical real-time systems, we need to be able to decide what data to send or not to send, and hopefully do that really fast. So we're sort of offloading that problem to the transport itself, the streaming protocol with MoQ, and basically doing something similar with having these latency targets and just trying to send as much data as possible within that latency target. So a lot of the strategy just comes through in how we divide up the data between the different MoQ tracks. And our preliminary results are that it works pretty well and seems to offer much better application level performance without much change. And we can have really fine-tuned control over what our target latency is, and that has a direct effect on our application accuracy. And then finally, I think this is the last big thing here. We're starting to look at 4D Gaussian splatting. So if you're not familiar with Gaussian splatting, it's a way of taking multiple images, get this to show here, and producing a fully interactive 3D environment where you can control the camera with 6 degrees of freedom. 4D Gaussian splatting is taking that concept, which is usually just one static environment, and doing it for a video, so that you have basically a 3D Gaussian splat for every frame and time. So this could be like 30 frames per second in this example, and you can move around basically within the video in 3D space. So a very interesting problem that's being worked on from like the graphics point of view, and we're starting to explore how we can tackle the streaming problems that come with this. Gaussian splats are a ton of data, so we're starting to explore again how we can divide up these Gaussian splat representations to different MoQ tracks to support viewport adaptation based on client-side controls, choosing what data to receive and when, and combine this with bespoke scalable compression techniques that we're developing to be able to, scale up the quality based on our available bandwidth, and hopefully do so automatically. Again, with a lot of our MoQ work, we're kind of trying to avoid explicit client-side adaptation for choosing like the quality level, like you do with Dash or HLS, these traditional ABR algorithms. We're really trying to take that problem away from the client side and just offload it to MoQ itself. Just try to max out our bandwidth, send as much data as possible, and see what more we can do. Hopefully we can get much more data through. That's what our results have shown so far. And we can start to explore these problems where we're dealing with way more data than we do with traditional video. So that's been an interesting problem space that we're looking at. Cool. And sorry for the sort of rapid overview, but I don't want to take too much time, and I want to leave time for questions. One shameless plug I'll throw in here is that the Baylor Multimedia Lab here is actively seeking industry partners to maybe pursue collaborative R&D projects with sponsorship. So if you're interested in that, let me know. But otherwise, you can connect with me on LinkedIn or check out our website here at these QR codes. So yeah, thank you guys. And we can open up for questions if anybody has any.
Amazing. Thank you so much for this presentation. I will try to break the ice. First,
Okay.
one thought I have after like looking at all the examples you are showing us, it's like my feeling is that this is like let's see if you agree with this sentence. It's like MoQ is enabling for us an alternative ways to share video, to do video. I think like HLS and Dash is very like traditional, but all the examples you're showing us here is like use cases that, again, HLS and Dash does not fit on this. And even like the last one about the 4DGS is like, I don't know, I maybe imagine sports being like that, and maybe with my glasses trying to see the basketball match or something. That probably that's something with current technology we cannot achieve very well. So
yeah. I can kind of elaborate on that a little bit. I definitely agree. It's like a lot of the things that we're exploring, like theoretically could be done actually with these traditional protocols, but it would be way harder, way more difficult to develop. Whereas, we've been able to explore all these different ideas within just over a year is when we kind of started up all this a little over a year ago. And so we're able to very rapidly prototype because the generic nature of MoQ transport makes this very easy, right? Compared to the very rigid structures of Dash and HLS in particular. So we can explore these new ideas much more easily, which is great, especially from a research perspective. Rapid prototyping is easy. And we're doing all this while the protocol itself has super low latency, which is nice. So we can get those benefits. And I think it's going to be, not just for us, but for, companies exploring these types of problems in the future, much cheaper to develop these novel applications. Takes much less manpower and less time and less infrastructure as well to maintain them.
My last question, because I have a lot, but I want other people to ask things. It's super interesting what you're doing also for multipath. So have you found any gaps on current drafts or specs for MoQ transport, for example, to enable multipath?
We're still in the very early stages of that. We're sort of awaiting financial support to continue that work at this stage. So most of what we've done is actually just exploring multipath quick itself and trying to get a network simulator environment that has multipath quick working. I think we've pretty much accomplished that recently, and so now we're starting to try to integrate it with a media over quick reference implementation and see what problems we run into, and then the lessons we learned from that, we'll try to see if any changes might be necessary in the MoQ specification itself. We're not sure yet, but it might be the case.
Great, thank you.
Yep.
Luke, please.
I'm just going to say on that front, if you need help, the IRO guys have a multipath quick implementation, I think, that should work with my relay. So it might be easy just to get off the ground.
Okay. Yeah, that's good to know. I would have to ask my students, see what implementation they're using currently. But yeah, I'll look into that. Thank you.
Any other question for the audience? Please, Herman, go for it.
You talked about kind of a verification system, right, where you can check when, let's say, content was tagged as sexual related or drug related, for example, and you can kind of verify whether the content is of that nature or not. How costly do you think that particular feature would be?
Cost to whom? That's the question. Who are you asking about the cost?
Well, let's say not. Do you think that it would sort of have an impact on the client's experience when they're interacting with the content?
So for the analyzer clients, hopefully no. That's the goal with how we go forward in designing these algorithms, right? So like if an analyzer client is running a whole bunch of analysis in the background, that could be draining their battery and making them unhappy if they're like on their phone or something like that. So we'll have to be careful as we design these to optimize for that quality of experience as well as for the user filtering. The filter cost is like computationally insignificant, like virtually nothing to blur a frame in JavaScript or modify a single image in some way. Like that's very cheap, so I don't think that's going to cause any issues. But yeah, we'll have to do a lot of work to figure out what is the rate at which we assign analysis tasks to a device. Maybe a device is only analyzing one frame every second or one frame every couple of seconds. But then if you have a sufficient number of users and you divide up that analysis for all those frames across all those users, then maybe that tiny impact gets, you build up and you actually have useful results for the whole video stream. That's the idea there, is we want to minimize the cost, both financially and to the QoE as much as possible.
All right, great.
Yeah, thanks for the question.
Adrian.
Very cool indeed. Bunch of stuff in there I liked a lot. And in particular, the kind of it's not traditional ABI. You're handing off that responsibility to MoQ itself. I think that's a really strong idea. Have you looked at how that plays with, I don't know, particular codecs, or whether you could start to push that all the way back through to kind of region of interest encoding, so that when you're in consistently degraded environments, you still get the best you can out of it? Is that an area you've explored?
Not in terms of like actual hands-on implementations quite yet. Yeah, we've mostly been exploring these kind of non-traditional representations, is what I like to call it. So like non-traditional video. But we do have some work in the pipeline with traditional video and exploring things like that for surveillance cameras in particular, where yeah, exactly. That sort of thing could be super useful, especially, any system where a human is not necessarily the primary person ingesting that data. I think we can actually benefit quite a lot from this offloading of the adaptation, because like if the quality of experience, like if there's one frame drop or a couple of frames dropped, it's not a big deal to an analysis application, right? So we can really explore a lot of that. So
yeah, and that goes all the way through to some fairly mainstream use cases. So, for example, we do a lot of financial fair disclosure live events, where actually the timeliness or the consistent timeliness of the data is more important than the video quality. What
Right.
matters in a financial fair disclosure event is the slides and the audio. And as much video as I can get is a bonus, but it's definitely a bonus. And so it's how can I deliver the best user experience to all of my consumers, regardless of how terrible their network connection is. That's I think there's some exciting stuff there.
Yeah, for sure. Yeah, and I think that could be an area where MoQ could help for sure.
Thank you, Adrian. Thank you, Andrew, for your presentation. This is amazing, all the work you're doing. And if anyone else has another question, you can find Andrew on LinkedIn or by mail, whatever. And again, thank you.
Are the slides available anywhere?
Andrew?
If you send me a message, I could send you the slides. But I think this is also being recorded, right?
Yeah, this is being recorded. We are going to upload to our YouTube channel. Agustina does all the job for us. So thank you, Agustina.
All right, thank you. Thanks, everyone.
Thank you. Great. So let's continue to the next talk we have today. So now, James, I don't know if I can spell this well. Hynard, is that okay? The way to spell
Actually pronounced it correct. Better than most people from England pronouncing it.
Yeah, really? Okay. James, a very good friend from us. He's business development manager at Qualabs. And he has a very, very super hot topic nowadays also, that is C2PA and how we can, the limitation opportunities there. So the stage is yours, James.
Sure, thanks for having me. And yeah, if anyone saw my talk at the Qualabs Tech Meetup a couple of weeks ago, they'll know that I like to do something more fun. Sadly, because this is a call, I cannot throw alfajores through the screen at people. Stay listening until the end, and there is some news around the alfajores. But let's get on with C2PA soft bindings. So for anyone who hasn't heard of C2PA before, just a quick background to this. So essentially, everyone knows that news and information is becoming more and more of a hot topic. And with the advent of AI, it's getting harder and harder to actually determine what's real and what's not. You can literally look at the news going on now in the Middle East, and you cannot even tell the difference between something that happened several years ago or if it's completely AI generated. And this is basically what C2PA is trying to solve, is to come up with basically the mechanisms and the standards to actually provide this information in the media itself, so that then consumers and also journalists are actually able to determine this without having to question everything that they're seeing. The other aspect of C2PA is basically trying to make this open for everyone, trying to make this as understandable as possible, that you don't need to have a master's degree from Baylor University to actually understand if something has come from the original source. And then basically try to rebuild the trust that you used to have in media in a new digital age. So C2PA, what is it currently doing? What should it be doing in the future? So again, if you do not know what C2PA is, this is not a character from Star Wars. This is a movement that is joined by multiple different organizations, ranging from the BBC, Adobe, Microsoft, lots of public broadcasters, as well as tech vendors now who are providing their influence and information there to try and drive the standards to make this as accessible as possible to the widest audience possible. So currently how this is working, and this is what's called the hard binding, is essentially there is a mechanism to sign metadata, which then attaches information around when a piece of content was created, when it was edited, where it's been distributed to. And the idea is essentially that this is then carried forward within the content itself, so that by the time that it ends up on the end distribution platform or social media, this information should still be in there, and you can basically trace back the provenance all the way to the source of the camera. However, there are some issues. First and foremost, it requires every single piece of technology in the supply chain to actually support C2PA. So in a very closed system like a newsroom, theoretically, this is much easier because all of the tools are coming from the same place. And so this central tool can make sure that that metadata is then carried forward all the way from ingest through editing to the end distribution at playout. But what happens essentially if this, if you use a different tool outside of this very closed environment? How is the C2PA metadata then carried forward from your media asset management to maybe a local software that you're running to do editing? How do you get that metadata back if it has been lost? Also as well, metadata in when it's being re-signed. So whenever you make an edit to the original asset, the metadata is re-signed and the metadata gets bigger. And then you make another edit, the metadata gets bigger. Over time, the metadata has the potential to balloon so big that it could actually be bigger than the original content file itself. How do you handle metadata in this particular use case? The other aspect, which I don't really want to touch too much because this is probably a whole other talk in itself, is also the metadata management. How do you trust a particular user and a particular device? And how do you basically assign this trust, or different levels of trust, to devices and users and how they interact with each other? As I said, I don't want to touch that too much. I want to talk about basically the metadata as it is now, rather than what could be done with the metadata. So we've got a real world example. Again, these slides are basically photos of myself. I apologize for that, but I can at least agree to using my own photos rather than chasing other people. So what we're seeing on the screen here is basically a recent trip that I did to LA. If anyone has been up to the Griffith Observatory, I thought it was a good place to get a good photo of the Hollywood sign. It's actually quite far away. So I'm there trying to take a photo, and the Hollywood sign is very, very small in the background. So I was like, how can my LinkedIn followers who really want to see this image actually have a better image to look at? ChatGPT. So I went to ChatGPT and didn't really think about it either. And I just said, make the Hollywood sign bigger. I posted it on LinkedIn, not paying much attention. And then I realized, if you see in the top left corner here, C2PA content credentials are in the image. This is an amazing first step, because basically there is a standard now that is then showing to everyday people in a way that they will be able to understand that this has been AI generated. My destructive mind then went, how can I break this? So all I did, like I said, I took the original image created by ChatGPT, took it to my local editing tool on my laptop. This is nothing sophisticated. This is literally just what Apple has built in. And I just increased the exposure ever so slightly, reposted it on LinkedIn, and now the content credentials are lost. So yes, that's a good step that the content credentials are there in the original asset that's created by AI. But if you're malicious like me, I can then basically remove this and then start to pass off things that are actually AI generated as being real. Now we get into the fun topic, forensic watermarking. Again, I'm trying not to do a sales pitch, so shout at me and you'll get afahors later on. So what is forensic watermarking? Very simply, forensic watermarking is an invisible watermark which then embeds data into an asset. This has traditionally been used in anti-piracy, but then there is a huge use case for this in C2PA. So on the image on the left, this is basically a clear image. On the right, there is a watermark with a payload in this. But what does that payload mean? So the payload is in C2PA what's called the soft binding. And this essentially is the metadata backup for C2PA. So if you do something like I do and make an edit to the image and then post it, the metadata has been stripped out of the original file. But if you scan the watermark, you are able to pull up the data that was originally attached to this. This then solves multiple different problems. So one, again, if there's been any sort of accidental edits made to this, you can pull this up. You can then basically store all of the metadata outside of the file and then solving the ballooning problem, which basically means that the actual transport of the media file is then much more efficient. So you're not basically spending a lot of CDN costs sending metadata. You're only sending the relevant metadata and the content file itself. Again, if someone then makes malicious edits, this can then also form the backbone of a deep fake detection, which I will get onto now. Oh, actually, no, I won't. What's the soft binding not? That's actually more important. So I'm talking about this a lot recently, and people are saying, is this a deepfake detector? And then I have to clarify, what do you mean by a deepfake detector? Because they're essentially two different things. What basically the soft binding is a way of being able to say, is this asset originally coming from a particular source, and have there been any edits made to this? This is not a silver bullet. This is not a tool which basically says that this is AI generated, full stop. For that to work, you would need all of the Gen AI tools to adopt this, as well as also have some tools to read all the content in social media platforms to be able to actually do this. There is an issue there. You can maybe have some regulation in the EU or the US. How can you do this worldwide? Maybe there are some bad actor countries as well who don't actually care about this sort of stuff, and all of the tools are running through there. It needs worldwide adoption for something like this. The best that we can do at this current stage as organizations, news platforms, institutions, is essentially protect your own content and provide the tools to protect basically your reputation. Also, the watermark alone or the soft binding alone doesn't work by itself. This needs to work with basically an end-to-end C2PA infrastructure. So the metadata is still important. The signing is still important. The watermark essentially is the file backup to this. Now I can talk about deepfake detection. This is technically not actually in the C2PA scope, but by the nature of how watermarking technology works, it can be used to detect deepfakes, or at least detect edits to an original asset. So essentially, a watermark is covering the entire frame that you're consuming, which basically starts to then create some sort of heat map on the screen. If someone makes an edit to the original video or image, the watermark theoretically is then going to be damaged. Which then basically starts to provide proof in a very easy to understand way to consumers and to journalists where edits have been made. As my colleague Tasso always says, we are basically selling technology. We're not selling morals or ethics. So we can't say that this edit is bad or this edit is good. All we can do is provide the tools for people to make up their own mind. So what we have on the next slide is, again, another photo of myself. I'd like to say that this is actually not me. This is a deep fake of me onto a politician making a speech. On the left, I don't know if I can zoom in from here. I might have to actually go in. No, I can't zoom in at all. So essentially what we did is deep faked my face over a watermarked video. On the right, what we then basically are showing is this heat map where the watermark has been damaged, with two examples of what we've done here. One potentially malicious, the other one just something that could happen in a normal editorial process. So in the top right corner, you can see the clock. This might be something that say a newsroom receives a stream from a particular parliament. They might add something like a clock in the top right corner. Is that fine? Is that an edit? Is that edit okay? It's up to the user to make up their own mind on this. However, is it okay that you've then taken this politician and then made him look much more attractive and put my face on top of it? This is then where it comes to the user to make up their own mind. As I said, this is a tiny bit outside of C2PA, but it's basically expanding what C2PA potentially can be doing in soft bindings to not only do the backup of the metadata, but also provide the tooling for people to become more digitally literate and check these things. So they don't just believe what your uncle has posted on Facebook. They can check for themselves and say, has this been edited in a particular way? Should I trust this? Yes or no? That's, I think, everything. And right on cue, going back to Afajores. As I said, I cannot throw Afajores through the screen. However, I will be at NAB, and my plan is to bring Afajores with me. If you find me, you can have an Afajor. That's my promise to everyone on the call, or anyone who's listening in the future. Thank you.
Thank you, James. This is a very hot topic. Super interesting. Quick question for you. So is C2PA, I don't know, is C2PA working on like creating a spec also on how to do these hard bindings about watermarking? Is going to be a spec about how to do it, or there will be like other, like, I know, products, technology that are closed, not open source or something like that? Do you have any idea around that?
So there is spec work going on for the soft binding. From my understanding, I haven't had the luck to actually sit in any of these meetings, but my understanding is that this is a very, very high level conversation of what should be done. The thing with at least forensic watermarking technology is a lot of the technology is very hidden behind closed doors, and this can't necessarily be open source. There are multiple different vendors in there, ranging from sort of traditional competitors of ours all the way through to actual open source technologies. I know that Meta have a watermarking technology out there, also Adobe. Again, if you want to know about trying to compare and contrast different watermarking technologies, look at my talk from the other week on the Qualabs website.
Great. Thank you. More questions for the audience. Adrian, I don't know if...
Oh, yes, I was just trying to turn the camera on.
Yeah,
again, very, very cool. What's the current state of the art in terms of C2PA and live streams?
That's actually probably a better question to Nico than me. I'm focusing on the soft binding stuff rather than the signing for live. Nico, please actually.
No, yeah. The live spec, the signing for live spec, it's already done. And in fact, we from Qualabs, we are working on some reference tools to how to sign and how to verify, particularly in Dash.js player. We are finishing the work around the project to release it as open source as a reference implementation. And in fact, we are working on that nowadays. So we hope in maybe 1 month or up to 2 months, we're going to release it.
Very cool indeed.
More questions?
Are there any open source tools you can recommend for like looking at watermarking or like any sort of like steganography that's in a video or an image? Just a casual investigator.
Funny you should say that. So again, this is the talk that I did last time with Qualabs. So at the moment, so making it take a step back. So what we've been doing at Qualabs is trying to start up a open source testing framework for watermarking. And essentially, this is a way that you can compare and contrast different watermarks out there, testing multiple different things about durability of the mark. What can it survive? For example, can it survive this particular type of crop or this particular type of edit? And this is particularly useful actually for C2PA because the Meta mark and the Adobe mark that I've just mentioned, which I think were specifically designed for C2PA, are open source. So we have been able to actually take that and run our testing framework on this. This is available at the moment, I believe, only under NDA, so ping me. But the idea that we have and what I've been doing in the past couple of weeks is actually trying to find a home for this testing framework. As I said the other week, this makes no sense that this has got our company branding on this because it looks like we're marking our own homework. Eventually, hopefully, this is going to be somewhere else where anyone can just get access to this, pump in the watermarks that they would like to look at themselves, and then make up their own minds. We're a bit of a way from this right now. So if you want to do some initial testing, message me and I can help.
Great. I'm just summer camp videos. This is the talk James is talking about. I just left the video over there, and you can see all the funny flying alfajores over there.
And if you want to run this through MoQ to get rid of all of the swearing that I'm doing in the thing, please do.
Great. Any other question for the audience? Great. I don't think I was thinking about while you're giving the talk, like the image you put the clock, and it could be like a logo, because maybe
Yeah.
I'm burning the logo of my Dolce Vele. I don't know, whatever. Maybe this is a good idea for, hey, maybe if we do overlays now with this, we don't have to touch with the video, at least for the basic stuff, put just the basic banners, titles, or clocks or logos, and that will be a great way to don't touch the video, please, for very important, sensitive information for everyone. That could be interesting use case to not touch things and leave the source as it is.
That opens up a whole other load of questions, because then what happens, because if you're thinking of doing this as an overlay rather than actually burning into the pixels, there are legitimate use cases where you basically need to take the original assets and put it somewhere else. How do you carry forward those overlays? Again, if you're being malicious, you can get rid of.
Oh, they need to have also C2PA, in fact, because
yeah.
And in fact, there should be a binding about, oh, this is the actual overlay that I want with this video. Oh, that's interesting. Okay, let's keep the Pandora box closed for a while.
There's too much to do.
Yeah. Okay. Thank you, James, for your talk today. Again, thank you, Andrew. Thank you, James, for being here. Two amazing topics, very hot topics, and we have a lot of stuff to keep learning and to keep in touch on with all these new technologies and use cases. Thank you, everyone, for being here. It was great to have our first Monthly Tech meetup. Also, at this time slot that it works for everyone, also in Europe. So thank you, Adrian, for being here. And yep, I hope to see you in the next one. Probably the next week we are going to have a Mate talk. The other format we have that is more a roundtable talk. And well, see you in the next one. And thank you for being here. Ciao.
Thanks, guys.
Bye.
Thank you. Bye bye.